Hello everyone. In this video, I'll explain the basics of Git. First, let's have a look at the components. When you put a project under version control with Git, you have three main components. There is the working tree, the index, and the repository. The working tree, that's the currently checked out version of your files. And these concepts will make sense a bit later when we have moved further in our explanations. The index is also called the staging area. And the repository, you can think of it as the history. Now, what files or what directories are we talking about in these three components? The working tree, that's everything that is outside of that .git directory that Git created when you started version control on the project. So basically, the working tree is made of all of the files that you have created. Those are your files. The index is a file in the .git directory, which is called index. And your history is stored in many directories called that are in a directory objects within that .git directory. But maybe it's more meaningful to consider the state of files rather than the nature of the files. The three very important categories or components when we consider the state of files are modified, staged, and committed. When nothing is modified in your project, when nothing has changed in your working tree, we say that the working tree is clean. Now, let's create a new file. Let's call it file 1. That's a modification, obviously. So file 1 will be pointed out by Git as a modified file. And if we want to stage it, the command to run is git add and then the name of the file. So in this case, git add file 1. If we run this, file 1 is staged, it's moved to the index, and it is now ready to be committed. When we commit, what we really do is take a snapshot of the project associated with a commit message. The message describes what we are committing. The command is git commit -m for message, and then your message, which is a description. Traditionally, the very first commit has the message initial commit, though there's no rule about that. So an example could be git commit -m initial commit. If we run this command, we create a first snapshot of the project with only file 1 at this point and file 1 in that state. So, of course, file 1 is still in our working tree. The file that you created, it didn't go anywhere. The fact that you have taken a snapshot of the project hasn't made your file 1 vanish. It's still there, it's still in your working tree. But because it has been committed and there is no uncommitted modification, our working tree is clean. So Git will not point that file to us. Now, what happens if we make an edit to file 1? Well, suddenly, file 1 reappears in our modified files. And what if we create a new file, file 2? Well, same thing. That's a modification as well. Our working tree is not clean anymore. So Git shows the new and the modified files. And they will have distinct labels. I'm putting them together here to simplify. When we'll go over an example tomorrow, you'll see there's a distinction between the two. So we can stage those new changes. We can stage all of them, or we can stage only a few of those. For instance, let's stage that new edit that we made in file 1. We run git add file 1, the same command as earlier, and that will stage that new edit of file 1. But if we make a new edit to file 1 reappears in the modified files. And so you can see that now file 1 is in two states. It's both modified and staged. Also, we don't have to stage an entire file. For instance, that edit 2 of file 1, we can stage only a little bit of that modification. It's called a hunk. And the command for this is git add -p file 1. And that will start some more complex code that we'll go over, but just realize for now that you have a lot of flexibility in what you decide to stage. And the staging area is a very important place because that's where the commits get organized. Think of it that if commits are snapshots of a project, you want to organize your snapshots. You don't want to take pictures at random and have some chaotic mess. You want to create a history that is meaningful with a bunch of changes that make sense together. So the staging area allows to take a bunch of modifications from your working tree and select those and then commit them together to create a meaningful snapshot. So once you have committed your changes, the version of that file is archived. It's part of your history. But be aware that information in the staging area can be overwritten. It's only once you have committed that you really have written a bit of history. The staging area is just a place to organize the next commit. So for instance, let's make a new edit in file 1. Let's call it edit 3. And we still have this little bit of edit 2 because we only committed a first hunk of that bit. So we have two modifications now in file 1. We have a remaining bit of the edit 2 and edit 3. Okay. So we can stage it, that third edit. So we still have file 1 showing in the modified files because we haven't staged everything, and it is showing in the staged files because we have staged that third edit. Now let's make a new edit, edit 4, but let's make it in the same area where edit 3 was. For instance, it's the same sentence or the same line of code, the same paragraph. So there's an overlap. Now, if we stage that fourth edit, it will replace edit 3. So edit 3 is lost. It's only when you commit that the state of a project gets archived into history and you can recover it later on. So now, if I commit that edit 4 with git commit -m and then whatever message describes what edit 4 represents, now that is in our history. That you won't lose. Now, it doesn't make sense to put every single file under version control. Source code, scripts, manuscripts, text files that you can't reproduce, those definitely you want to put under version control with Git. But the outputs of files, those that can be reproduced extremely easily by rerunning some code, you really don't want to version control those files. So let's imagine that file 2 is one such file. It's the output of running a script, for instance. So we're not going to put it under version control, but we also don't want Git to tell us that there is this unstaged file, file 2, all the time. We want to be able to have a clean working tree. So the way to go about this is to tell Git, okay, just ignore file 2. Don't worry about it. And we do that by adding it to a file that we create that is called .gitignore. In Linux, all the files that start with a dot are hidden files, and so that .gitignore is one such hidden file. So from the command line, for instance, you could simply do echo file2 being the name of that file we want to ignore, and send that to our .gitignore. So I'm going back. We have a file2 as a modified file. If I'm running this echo file2 and I'm sending it to a .gitignore file, file2, it doesn't disappear obviously, but Git doesn't tell us anymore that it's a modified file. However, we have just created that .gitignore file. So now Git tells us, hey, there is a modification there. There is this .gitignore file. So file2 has now become invisible to Git. Git is never going to bother us with that, even though, of course, if you go to your project, you'll still see it. And we have to take care of those .gitignore file. And it's just like any other file. You can stage it, commit it, and take care of it as any regular text file, because it is a text file, and you want to stage and commit it. So all this archiving is great, it's nice. We have created a history with 3 different snapshots of the project, but how do we return to old versions? Because the whole point of creating a history is that we can make use of it, right? So right now, we can't recreate the past. We can't return to one of our previous snapshots because we have all these modified files. We need a clean working tree before we can go to a previous version. So we could commit them all. So we could stage them all and then commit them all and create a 4th snapshot of the project. But there is an alternative, because maybe you want to go back to the 2nd snapshot. Maybe you want to look at it, you want to see something, you want to copy bits of a file at that point, but you aren't ready to create a new commit with those modifications that are in your working tree. So the alternative is to stash them. That's kind of, it puts them out of the way temporarily, and then you can retrieve them. The command to do that is git stash push. And if I do that, hop, all of those changes, they're put in that little stash kind of like on the side. So we don't worry about them for now. They're not lost, but our working tree is clean. We're ignoring these bits for now. So since we have a clean working tree, we can go back to that old version, and that's called checking out. But how do we know how to get there? So how to find the information for that 2nd commit? We need to find its hash. The hash is a unique string, a unique identifier that allows to identify individually every single commit that you do. And the way to find that hash is to run Git Log. Git Log will list all of your commits with their hash, so they're a big string, their author, so that's going to be you if you're the only person who has committed in this project, by date, and with their message. And that's why, by the way, it is very important to have an informative commit message. Because if your commit messages are 1st commit, 2nd commit, 3rd commit, it's not going to be extremely helpful when you look at your Git log to find the commit you're interested in. If you write informative messages, that's going to be a lot easier to find, oh yes, that's the version with this and that. All right, okay, easy. So you run Git log, you find the hash for that 2nd snapshot you're interested in. Now, to check out that commit, all you have to do is run git checkout and then that hash and a dot. So look extremely carefully at our working tree. So, of course, because it is clean, Git is not gonna show anything in the modified state. But if you go to your files, if you go to your project, the files look like what they're at their latest stage. But if you run that git checkout hash dot, attention, badam, we suddenly move back to the state, to the history, to that point in time in our project that we took a picture of when we recorded that second snapshot of the project. We have checked out that second snapshot. We have gone back in time to that state. You can now explore those files. You can see things the way they were then. And we're clearly back in history. Now, what if you want to go back to the latest version of your project? You've seen what you wanted to see. Now, okay, you want to go back to that third snapshot. Well, since you have a clean working tree, no problem. You check out your latest commit with git checkout hash of the third commit. Again, you can find that hash with Git Log. Et voilà. Now we are back. If you've noticed on the modified working tree, we are back to the latest state. And again, it's a working tree, so Git is not going to show you everything. But if you go to your project, if you open your files, they will now suddenly be back to what they were when you created your third snapshot. Now, what if you want to retrieve those changes that you stashed? That's called reapplying the stash. In order to do that, you run git stash pop, and all those changes that were on the stash that you had put aside to have a clean working tree in order to check out a different commit, you've been reapplying them. So suddenly your working tree is not clean anymore, and you can see you have again that .gitignore file that's there, and that hunk of the edit number 2 of file 1. So that's it. You're back to where you were before you stashed, checkout, and etc. So that's it for this very first short introduction, but tomorrow morning we will practice, we will put our hands into it, and if some of the stuff didn't make a lot of sense right now, it will make a lot more sense then.